So my name's Ingy.net, and thank you. I really like to work in a lot of programming languages. So my first Perl module was called inline PM, and that actually bound, you could just write C code inside of, everybody who's heard of inline, you can just write about any language inside of Perl. And then I got about 100 plus modules, maybe 200, I don't know, on CPAN. Not all of them are great, but some are good. And then I started branching out to other languages, Python, Ruby, Node.js, and Perl 6. So what I really want to do is write a module once and publish it to all these languages. And I've had this idea for about 12 years. And at some point I had the domain acmeist.org, and I'm like, that should be the name for my philosophy of programming everything to all languages at once. So I put a little blurb on acmeist.org. And I like inventing new languages, so I was one of the creators of the YAML language for data, which is pretty popular. Thanks. This new language, schema type, is a schema language for all data languages like YAML, including all the way to SQL. And if it is accomplished and meets its goals, it will actually, usually a schema language is to validate data, but this is to actually generate all the code around data, so that to eliminate 50% of programming by just defining a set of data and generating the whole stack that has to deal with that data. And Swagger does that for their API stuff, so it's doable. Gemplet was a templating language that I took template toolkit and ported it to JavaScript, and then last year I actually ported it to Lua for a company called OpenResty. So that's an acmeist project. PegX is a parsing engine that was inspired by Perl 6 for every language that has PCRE regexes. Actually, it's not even, any language that has regexes can do PegX parsing. And Lingy is my latest language. Well, and you'll see that today. It's Lisp plus JSON. But we'll get to that later. So TestML is a new language. It has a compiler. It's actually a transpiler. It translates the new TestML language to Lingy, and Lingy can run in any language. So it's very data-driven, so you write very little code, even TestML code. It's usually one line and then thousands of test cases. It's going to work in every modern programming language, but currently it's working in CoffeeScript, which I count as a language because I actually run just CoffeeScript, JavaScript, Perl, Perl 6, and Python. And it's easy to port, so as soon as I decided I'm going to do it all paired up with other people, so I'm just going to find a language enthusiast and grab them and say, hey, let's spend an afternoon making TestML in your language. But not only that, it works with every testing framework. So in Perl, we almost, well, Chad probably has some new stuff, but we do all TAP. But in other languages like Ruby, they have 5 different programming or testing frameworks, and it's meant to work with any testing framework. And you'll see that I actually have, in Python, I have TAP. I put TAP into every language so far because it's so easy. But there's an XUnit runner for Python and a Mocha runner for JavaScript. This is really great for multi-language projects like YAML. So the whole YAML test suite, which I'll show later, is in TestML now. And, but it also works great for everyday programming. It's actually 15 years old, and it comes from the Perl module test base, which when I worked at Social Text, I put it out there, and people like Miyagawa started using it for everything. If you've ever heard of, who's heard of Agent ZH, who made OpenResty? He's also a huge CPAN contributor. Just produces tons of code, very performant code. He's given some YAPC talks before. He has about 120 repos, projects that make up OpenResty, and they all use TestML for every test case, and he writes thousands of them. Test base it uses. So last year I actually worked for him and wrote TestML, which you're going to see today in 5 languages, internally for him. In 3 languages, so that, but he allowed me to open source the code, so I rewrote it in these languages. By the way, this is Vroom. It's a PowerPoint in Vim. And I've been using it since 2008. I wrote about a dozen slideshow things. Spork, anybody heard of that? But this is just the best one. I added a little feature here so I can actually run commands from it in this show. I'm going to run a lot of commands. So this is just my slideshow. And when I run vroom vroom, it makes it into this. Okay. So TestML has a pound TestML, and if you want to go there, you can go there now. And if you have a computer, this isn't one where I care if you're looking at your computer. Hopefully you're looking at my stuff. And you can ask questions there, and if you raise your hand, I'll try to answer a question from IRC. But do go to testml.org now, and then up at the top there's a playground button. So all of TestML, since the compiler is written in JavaScript so that I could run everything in the browser, and all of the tests for TestML, all the tests for the compiler are all in TestML, and you can pull down any of the tests and run them right in the browser, and they run instantly, and you can change the input. Actually, I'll just show it to you. Okay, so here's some TestML, and let's make it fail. So we'll change this to from, and it instantly fails, right? And then
Zoom in.
Oh yeah, sorry. There you go. Okay, so I'm going to change a data value from 3 to 34, and a bunch of tests are going to break, and I'll change it back. But you can, it's interactive, so you can change the tests and get instant things. You can also see in here a different, so this is Mocha output, and this is the TestML that you see on the left compiled. So this is actually Ingy, the compilation unit of this TestML program. More about that later. So yeah, but you can actually play around with the concepts that I'm showing up here in that playground. So I'm going to give a rotten example of using TestML, where rotten is rot 13, but 13 can be any number, so it's rot n. So here's the CoffeeScript version of my rot n library. I wanted a library that had an API, and so it has the rot method that takes an n. You instantiate a new object with a string, and then it converts the string internally. So you can actually chain it. You can say, you make a new object with some string, I like pi, and then you rot 5 it, and then dot rot 8 it, and then that's a rot 13, and then you dot rot 13, and it's back to the original, that kind of stuff. So this is that class in CoffeeScript. If I go to here, you can see this is in every language, so let's look at it in Perl. This is the Perl, looks about the same if you squint. And let's look at it in Perl 6. Oh, isn't that beautiful? Okay, so now let's run this test suite that I wrote. So I'll show you the test suite in a second, but I wrote a test suite for rot n that will run in every programming language that TestML is implemented in. So here we go. So there's Coffee, there's Node, there's Perl, here's Perl 6, a little slow, and there's Python. Cool. Let's just run just Python. So there we go. It's running one of the tests, and then this is the second test. Okay. And let's look at the library. So here's the lib that you just saw, and here is, sorry. And here's the test suite. We'll look a little bit more at that in just 1 second. Okay. So here's TestML in a nutshell. Here's the tests that actually, part of the test that we were running just now. So you have a hashbang line, and in proof, the hashbang line always honors whatever, actually in Perl 5, if you run a Python script that has Python, hashbang Python, it will run the Python script. It just execs whatever's in that hashbang line, which is a really cool thing. And if you write TestML and you run Perl TestML, it'll invoke TestML, or if you run proof TestML, it'll run proof. Here's a label for the test. Now, what this plus does is tack on this part of the label down here from each test block, and you'll have like many of these test blocks. This is called a test block here. There's an implicit loop around every top-level statement that says run this against every test block that contains all of the starred elements, and those are called points. So star input and star R13, ROT13. This test block has both points, so we're going to use it. And then I have an interpolation of the input value will get put into the label. So the main thing that has to happen in TestML is an assertion. There's 3 types of assertions, but they're polymorphic, so it expands to about 20 types of assertions. Like the equals equals has 3. It'll work on currently strings, numbers, and Boolean, but you can't mix those. And then I have a regex type of operator, and you can use that on a string against an array, regex, but you can also use it on an array of strings against a regex, or a string against an array of regexes, or an array of strings against an array of regexes, and that'll just multiply out the test case. I'll go into polymorphism in a bit. So bridge methods, this is where the rubber meets the road here, and we're going to look at this. So in this case, there's a bridge method for every test suite that contains all of anything that's a lowercase word in TestML is considered to be defined by the user. Everything that's uppercase, starts with an uppercase letter, is defined by TestML. So in that test that we saw, if we can, the test is here. We have this rot method right here, and it has to call something. It actually calls Perl, or it calls Python, or Perl 6. So we have, in each of these bridge classes, we do the little bit of work that we have to do to talk to the library or application or whatever we're testing. And some of the bridge class methods just stand alone. You can just do them right in the code themselves. But the real purpose of bridge class is connect TestML to your application. Okay. Does everybody understand the bridge class concept? So basically, when you have a test suite, and so the deal here is, when I write Perl tests, I write them as not test.tml, but I write them as test.t when I'm shipping them anyway, because proof will just run them, and if they happen to be TestML tests, they'll run as TestML if they happen to be Perl, and I can mix and match. I'm not limited to taking on all TestML. I can just throw a few TestMLs, or I can pull a whole suite along with my other test more tests in there. It all works really well. So that's, hopefully everybody, I hate when I do that. Okay, and we want to go over blocks and points. So here's some command line usage of, so TestML has a full command line, just like Perl does, and so if you do TestML -h, then you get the short help version. So in this case, we got an error because TestML by itself has no idea what language you're running. And there's a lot of ways that you can specify that, and we'll see some of those. So in this next example, I put it in an environment variable. I said, okay, my runtime is Perl 6, so let's run, it's the same test as the one above that broke. Let's go back to that. So can't determine the TestML runner binary to use. Try setting one of these variables. So we do. And we get that test to run. Or you can use the -r flag, which is --run also, and run that, and it works. Or all of these actually expand to the runner that they use. So that R was actually invoked TestML-Python-tap. But in this case, I'm going to use TestML Python unit. Unit test is the framework that most Python people use. They don't use tap. Some may, but so let's run this. And that's what that would look like. Same test running in a different framework. Okay. So this is the compiled test in Ingy. You've already seen that. And TestML has a compile flag, so you can just actually compile it to see what it looks like in Ingy. So there's the compiler running. So here's a one-liner. I'm going to take, I'm going to run coffee tap with this one-line thing. Notice it's a capital S sum, so instead of a bridge class method, that's going to call what's called the TestML standard library. And right now there's about 20 standard library functions, or methods, because they're chainable. And so we run this, and it works. There's no label, so you didn't see no label defined. Okay, and this is running the stuff with proof, right? So I had to set the runtime. You can actually set it in a config file. So if you're only doing Perl stuff or only doing tap, you just have a TestML config file and just set it there. So I say prove -v, this thing, and it just works. And if I took off the -v here, I could actually edit it because I'm in Vim. And I say this. Great. So, okay. Here's some one-liners. Okay, so we saw a one-liner already. Now what happens if I run this one-liner? It should fail, right? And it does. It says that what happens if I run this one-liner? I'm trying to compare a number to a string. So this is the kind of crummy error message, but you get method assert num equals string does not exist. The error messaging will get good, because actually all of this work was conference-driven development. I'd already done this for that company last year, so I knew what I was doing. Conference-driven development. So I wrote all of this code in 5 languages in the last 6 weeks. Which is a testament to how easy it is to port to these different languages. Because I'm not really that fast of a programmer. So, okay, so I tried out all the languages. The only language that supports multiple -e's as if they're separate lines is Perl and TestML. But Perl 6 doesn't do it, Python doesn't do it, CoffeeScript doesn't do it, etc. JavaScript doesn't do it. Also, I added semicolons to the grammar. So now if there's one space after a semicolon, you usually want to put a space after a semicolon, then it just puts all the lines together. But look at this next example. I put 2 spaces. If it's more than 1 space, that's actually indentation, and this is an indentation-based language you'll see. So this is defining a function. So I'm saying take this array, and for each element, call this function, but the function element lines have to be indented. And so that works. This is the last thing I wrote 2 minutes before I stepped up here, and it doesn't, and for some reason it's not working. I don't know why, so. I think the rest of them work. Okay, so here's a little rant on testing and programming. Too much code is a bad thing. And actually, I think that companies that pay tons of programmers to write tons of code are just sinking themselves, because now you have to maintain it. But tests are code, and so you kind of double the size of your code base if you write a lot of tests. And if you don't write tests, well, Booking is really into not writing tests, and maybe it's a good idea because they don't want to sink their whole ship. It adds to your maintenance problem. But when tests are mostly data, it's much easier to maintain, because when you're maintaining data, you don't have to figure out what side effects the number 3 has. It's just the number 3, and if it's wrong, then you change it to the number 4 or whatever. So TestML is almost all data, and it makes testing not suck. And that's why Agent CH, the most prolific programmer I ever met, uses TestSpace completely, because all of his tests are data. So code should be mostly data too, but that's a whole nother talk. That's my schema type thing, maybe next year. So I kind of gave this a little bit. I started off in 2004. Me and my friend Ryan were working at Social Text. We came up with this little test format. I published it on CPAN as TestSpace. Acmeism came along like 2008, and then I'm like, I should make TestSpace work in every language. And I made my first version of TestML, which is actually on CPAN now. And I actually use it to bootstrap this one, because the compiler is all written and the tests are all in TestML. But if the compiler's not working, then you're screwed. So you just use an older version of the language. That version was very heavy and hard to port. This version is very light and easy to port. Last year I worked at OpenRusty. They let me invent the whole language all new. And this year I opened it up. And that's what you're seeing now. So we go to noon, right? Is that right? We go to noon? That's how long this talk goes. Okay. So you're kind of getting this already, but when you're using TestML, you have some software that you want to test. You might have a pre-existing test framework, because you just learned about TestML. You need to get the TestML framework. Now, for Perl, this is going to be available on CPAN and 6PAN. It was too much for me to do it right in the last couple of days. I tried and failed. So it'll be out in the next week, for sure. And you need to write a bunch of TML files with simple assertions and a large body of data. You write your TestML bridge classes. Usually these are really small because they're just loading your application and calling your methods. So, and then you just use the TestML CLI or use prove. Okay. So I'm going to run the entire test suite. I'm actually not, because it's, so this is CoffeeScript running all of the TestML runtime tests that are also written in TestML. In CoffeeScript and Node.js, this is the most terrible thing I found out about Node.js. It has a 0.3 to 0.5 startup time. It's quite fast once it starts, and it was introduced in a commit about over a year ago, and they've never fixed it. So it's really bad for writing scripts in that you have to repeat a lot of times, multiple processes. Perl is instant. I mean, it's like less than, I forget what it was, but it's super fast. It's about twice as fast as the true command, which just returns the number 0 to the shell. So, in my timing anyway. So I run it just in Python. Now all the tests they compile once, and when you change them, the compilation unit gets cached, just like Perl 6 does with their pre-comp stuff. So I run this, and so the runtime's quite fast, and once the compiler's fast, it'll be just as fast for that. I want to, well, I'll get more into that later. And so here's my library of all of the things that define the runtime. And actually, this is stored in a separate repo because I share this between projects. So if somebody else wants to just grab this test thing without grabbing my whole repo, they can use it and do their own thing in their own space. So that's kind of the idea is when you create a suite that you know is going to be implemented, multiple people are going to implement multiple implementations of some software thing, and you define one suite like YAML, then you just pull in the YAML suite and run your tests how you want to run them. But the suite is kind of its own unit, encapsulated. Okay. So the compiler is what really made this thing good, and I wrote it in CoffeeScript because I love that language, but also because at the end of the day it's JavaScript, and I wanted this stuff all to work in the browser as well as the server, and now it turns out it's just too slow to be the reference thing on the server. It's fine in the browser, so I'm trying to get this guy to implement it in Haskell so I can ship it as a standalone binary, but for now I'm going to fat pack Perl. Start in the hackathon on Thursday. I'm going to just do this because it's all in PegX, and PegX works in JavaScript and in Perl. So the port will be trivial, and then I'll at least have fast testing until the Haskell thing happens. So the compiler it's totally complete for all the language things I want. It's about 500 lines of of CoffeeScript, and then the PegX grammar, which I'll show you right here, is about 300 lines. And it just takes a TestML input and prints Ingy to standard out. Let's look at that. So there's a file, and then we'll compile it. There's the Ingy. And then let's look at the grammar file in PegX. It's kind of interesting just because it's so simple. I mean, this is what PegX looks like, and this is defining the entire language. Each one of these rules can have a CoffeeScript or a Perl or whatever method that it calls when something matches, and that's where the work is done. But the definition of the language is really easy to read in PegX. Next. So the compiler test suite, also written in TestML. I won't run the whole thing because not only is it compiling into, okay, thanks. We're halfway through, according to my front hand. Yeah, that's pretty good. Let's see. Yeah, so those were all the compiler tests also written in TestML. So TestML is really feature-rich. Simple things are simple, hard things are possible. And I'm going to show you the features now. So this is what, so this is a data block, like I said before. You can have one-line data blocks, and you put so you have a data block starts with equals, 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 and the points start with minus, minus, minus. And you can just think of this as a hash, where line and text are the keys, and the things after them are the values, and then it has a label that gets actually used when you run the tests, if the framework supports that. Now this is pretty cool. This didn't exist in the old TestML, but you can actually inherit the last definition of line in this new block like this, and then you can define a new point called more that's just actually inherits from the last time text was defined. So in this case, I put a colon after it, and I'm doing a single line with no new line at the end, and this is these two lines with the blank lines removed. And there's ways to keep blank lines that you'll see in a second. So here's the actual test for some of this stuff and how it compiles to Ingy. So you look, there's a data section. All the Ingy files have a code section. There's no code in this one. They have the TestML version, and then they have the data section. And you can see really easily that it has a label and a hash of points. And this is the exact value that was defined above. This, that, with no new line. This new line, that new line, defined above. Numeric points are stored as numbers in JSON. So we see numbers and strings here. So TestML has its own type system, and it uses all of the JSON types, plus about 6 more. There's about 6 JSON types, and adds about 6 more to that. And getting that type system right between the language and TestML that's the hard part. Once that's done, that's where I have to really concentrate, and it takes a while to make sure that's perfect. But I have a test that proves that it works now, so when that test passes, in Perl 6 it took me over a day to get right, because Perl 6 type system is sneaky, shall we say. In this case, the foo point has a blank line, but that gets stripped out, so that's empty. And in this case, there's nothing after the colon, so these both things are empty string. Here's the point in inheritance that we saw before. The foo here is getting XXX from the foo above it. Here's where we have bar is a point taking the foo value from above it. Here's some quoted things to show that the encodings expand, etc. So, we'll get to that in this next one. Okay, so I have all of these transforms, and these are really cool. And this is a new feature of the language. So in this case, imagining you're testing TestML with TestML, well, all these minuses and things are going to collide with each other. So what you do is you indent it over 4 spaces, and then you put this less than, just say shift it back. So if we look at the output, there's no spaces in front of here. If we took that less than off of there, there'd be 4 spaces in front of each of these lines down here. This plus keeps the blank lines at the end, so we can see now we have these 2 blank lines at the end of XXYY. Pound, anything a line that begins with a pound in column 1 is a comment in TestML. And this is really useful because sometimes you want to comment out data or code because you're trying to narrow in on what you're doing. But sometimes you actually want pound to work, and you could indent it. That would be one way to do it. Or you can just use the pound thing, saying, in this case, the pound is actually literal. So down here, foo, I kept the thing, but in the next one, bar, it was just a comment. I didn't say to keep it, so it wasn't kept. Minus will actually chomp off the final new line, so there's no final new line here. And these are all, these all kind of combine together. You can specify more than one of those in the parentheses. Let me get to some more interesting ones here. So this is going to turn this into a regex. And it's interesting here, the way I store regex in TestML internally, this is what I call the cooked type form, is as an array. Because in TestML it's a Lisp, so arrays with a string as the first thing is an expression. That's the actual code thing, so I have to discern that from here. So if I put a slash on the front, this is defining a regex. And I need to do this in JSON, so JSON doesn't support regexes, so this is the way I get around that. Tilde strips off the blank lines in case you want to kind of separate out your things so they read nice, but you don't really want that to be part of the test data. So now here's where it gets good. So @ will chomp this into 3 lines and return an array of those lines. Now here's the format that I use for arrays. If I have an array is for expressions, so an array whose first element is an array, I just wrap an extra array around it, and that's how I specify an array in Ingy. Here's a regex, here's another array. But the cool thing here is I use baz is @ slash. I have 2 of them. So this is an array of regexes, which I said before, when you use in a polymorphic context, you say string equals or matches an array of regexes, it will produce an assertion for each regex in that array. Very cool. It's probably enough about this, you kind of get it. So, oh, there's a new one I added recently. It's the double quote, and that will actually, I think it's down here near the bottom. Yeah, the double quote semantics. So if I actually want to have \t and \n work in my data, and actually, they'll actually expand those things. Somebody created a test with this, and actually, to do it really nicely and succinctly, they needed those semantics. So that was cool. Okay, and this is kind of there's 6 what I call pseudo points, and they're all uppercase, and they're defined right here. I won't even show the test. So you say, well, maybe I will. So here I define 3 test blocks. Let's see. Only is the most used one. Everybody loves only when they use this. So I have 1,500 tests or whatever, but I'm just concerned about this one that's failing. I can just mark it with only, and basically it's setting a flag saying, even though you defined all these, don't compile the rest of them, just pick this one. And then once I get it working, I take the only out, and I'm good. I'm doing all the rest of them. You can probably guess what skip does. Head says the list starts here, and yeah?
Can you have more than one only?
No, I don't know. Undefined behavior, and I need to define that, but I can see why that would be really useful. So,
Whether that would be a good or bad thing. But
yeah, to be determined. Good question. So we talked about this. There's an implicit loop around these. So I'm going to look for all the blocks that have a foo and a bar. But sometimes I want to do, when you define these blocks, you might have 5 different data points, and you're only using 2 at a time, or maybe 3. And so you can define all these different kind of tests where the data is all related, but in this one you want A and C, and this another one you want A, B, and D. And so that works out good. But sometimes you want to say, I want A and B, but not C. And so what this says, this is kind of like a conditional that says, baz isn't part of this expression, but it has to be part of the loop picking, which blocks I want. And so only take the foo and bar ones that also don't have baz. So these are the internal data types. I have string, numbool, list hash. These are the JSON types. And internally, I store all the scalars just as themselves. So a string is a string, a num is a num, bool is a bool, null is a null. The lists and the hash I just wrap with an extra array. But then I add these types. I have a none type, which is like returning empty parens or an empty array in Perl. So that's mostly for bridge classes saying I'm not returning anything. You need to have that none type. I have the regex type. I have a function type. Internally, everything's a Ingy expression, so that's the expression type. I have an error type to encapsulate errors, and actually I have try and catch. I don't get into that in here, but there's a catch standard library thing. So if anything fails, you actually want to test errors, use the catch. Because you expect something to fail, then you catch it, and then you test to make sure that error message matches, say, an array of regexes or something like this. And then native, when you're passing from bridge method to bridge method, TestML doesn't know how to deal with a native, but if I'm going from one Perl method to another Perl method and I want to pass a DBI object or something like that, internally in TestML, it'd be like, I don't know what this is, so I'm just marking this as native, and I'll pass it along. But by the time I do the assertion, it better be something that I know how to deal with, because none of the assertions work with native. The scoping is global, and that was just because it's quick. That doing function level scoping won't be hard, so not too worried about that. These are the operators. This is kind of weird for Perl people, because for me, it's just, all it means is like left side contains right side. So if the left side is an array, it contains the element on the right side. If it's a string, it contains a substring, that kind of thing. And these are all polymorphic. So here, equals has 3 forms. I only have one test for the matches, the like, or the regex thing, and the contains. But down here, I have blocks that test all of the different conditions. So I'm doing scalar. I'm doing, this one's actually scalar array, right? Because it's an array of regexes. This is an array of text against a thing. And anyway, does that make sense? Each of these blocks has a different data input form. So when you execute this thing up here, it might be an array here, or it might be a scalar, and this might be an array of regexes, or it might be a single regex, depending on what that particular block at the time in the loop has. Let's see. So, and there. So even though I had 5 assertions in there, it actually expanded to 21 assertions. You can see. This is kind of cool. I stole this from, if I interpolate a multi-line string into the label, I use this little NL character that you Perl 6 people know about. It shows up in all the Perl 6 spots. Although a lot of terminals, I got a couple complaints about it, so it might change. Yeah. So these are the operators in the language. Let me see what we got here. Assignment, you see, is just assigning a value to a variable, or equals, you know what that is. Point value means look up the value from the data block that's the current topic. Each says take I call arrays lists in TestML, so take a list and apply the right-hand side to each element in the list. This is a function definition, and everything below it is indented. This is a function with arguments, and so you can actually have a bridge dot, and then you call this function in line, and it'll pass the return value of a bridge function into a function that you can then do a lot of stuff because it's a function. Functions currently aren't functions in the sense that they do something and return it. They're actually ways of combining multiple statements into one unit. So I can say f equals arrow, and then 3 statements, and then when I call f, it's going to execute those 3 statements. But there's no return value yet, and I'm not sure that's necessary for this language. There's no keywords in the language, and that was on purpose because keywords get you in trouble, and especially when you're trying to implement in every language, you're going to have collisions, right? Because class is going to mean something in one language, and like I was implementing tap in Python, and I had a pass and a fail method in my tap library, but pass is actually a Python keyword. Python has so many keyword collisions, it's unbelievable. And I usually just tack an underscore on the end and say, screw you. So, okay, so here you can see some chained functions. Take some inputs, convert it into a set of lines, reverse the lines, convert it back into a multi-line text, and does it match the output? Does rot13 equal rot13, or you take the rot13 point value that it's supposed to match. Usually you would just say this, but it should also match this because I'm just rotating it all the way around the alphabet. And here's an example of what I was saying before. So this is going to run an IPC command. So I take a command out of my data block, I run it using IPC, and I'm going to get back a return code standard out and standard error, like try-tiny would, is that what's called try-tiny? Capture tiny would use. And since it's going to return an array of those things, and since the signature of this is 3 elements, it's going to expand that array. It's going to splat it out into these 3 variables, and then you can use the variables inside this function. So that's a great example of how functions work and how input arguments to functions work. Okay. So I already explained most of this, but I'm going to show you the standard library right now. So these are some of the standard library things that I have. Blah, blah, blah. Compiler directives start with a %sign, and there's only a few of them so far. You can say %testml to assert that you won't end up with a runtime that it wasn't compiled for down the line if you're worried about that. But it's optional. Import is great because you can actually import other TestML files into your thing, and you can do multiple ones on one line. I'll show you an example real quick. So here's an import example. So the YAML test suite has hundreds of tests here. And for this example, I just import, I don't know, a few of them, and then and here are them all passing when it gets run, and here's them passing in Mocha. So import data is for only importing the data section. So maybe you have some test and it has the data that you want, and you just want to use it in a different test. So you just say import the data, and I'll use my own test lines in this one. And so I kind of explained comments and only already, and only should be all caps there. But actually, let's go and look. Wonder if I can get through this. So, okay, I found a JavaScript. I would call it a bug. The modulo operator doesn't work with negative numbers. So all the other languages do, but when I try to write -1 in JavaScript, it doesn't work. So I'm going to save that, go back and try running it. I'll show you the fix. So the fix ended up being, you can see it down in that line that's commented out. That's how you kind of have to do a modulo operator if you want to use negative numbers in JavaScript. I'm running short on time, and it's not really, I was going to show you fixing it and running it and all that, but we'll skip over it. The YAML test suite I just showed you has all of these things, and I just showed you the import, so we're done with that. This one's cool. So my friend Tina, who does all the Perl stuff with me, she's one of the world's foremost people on Perl, and she's writing probably the best pure Perl implementation right now of YAML called YAML PP. And she had this test, and she had all of these little string niblets, and she wanted to try all of the scalar styles. So there's double quoted, single quoted, unquoted, and all that. And she wanted to test all of those. And so I'm like, I'll convert that to TestML for you, and here's what I ended up with. So here are all the scalar forms. What I do is I divide them into an array, and I use double quoted semantics. We learned about that already. And then I have a test block that each of the other test blocks, this is a scalar style. This means no quotes, this means double quotes, this means single quotes, and this means pipe in YAML. And this one I skipped with the skip directive because it doesn't work, or it's not applicable. It doesn't really work that way in YAML, so it doesn't round trip. And if I go back here and I run it, oops, then cool. And all the labels are really informative because they're telling me exactly what's going on. So that was kind of a neat real world thing I just did. So if you set a plan, 5 minutes? Okay. If you set a plan variable, so I made plan a global variable because most frameworks don't understand plan, but if you set plan equals 5, then it will actually work in tap because tap will look for the plan variable. And you can use this diff stuff. The diff says turn on diffing because, let's take a look at this example, and let's make it fail. So now the diff is really nice, right? But if I didn't have this diff turned on, if I said false here, then I got two, a want and an expected thing that are almost the same, and it's going to be really hard to figure out. So all of the multi-line stuff supports the diff option, except in Perl 6 because I couldn't find a good diff algorithm yet, but I will. I'll just explain this real quick. I test the output of all the command line stuff, like the help test and all that, just with more TestML. You can use it for all sorts of things. It doesn't have to be unit testing. It can be acceptance testing. All kinds of testing works with TestML. Okay, so this is the cool last example that I just finished in the last talk. I was thinking about this on a bike ride. I brought my bike here, and I was thinking, you know, you only want to write like 20 data blocks in a test, or maybe 100 or whatever, but after a while it gets unwieldy. But what if you could put all those in a database? And so, and really the data format is just a labeled hash we already saw. So check this out. I wrote a Perl program that generates, and let's run this. So this is generating some addition things. It has test 1, 13 plus 15 equals 28 is what I'm going to assert. And so now when I run this in TestML, and I'll have to show you, let's see if I can. I'll blow this up in a second. Yeah. Okay, so this is a standard method thing that I haven't added officially to the language, but I just wrote it in the last thing, and it says, take this SQL file and import this table that's expected to be in the format that we need here, and we run this, and it works, right? And so this thing takes a number, so let's make this, how big should we go? Oops. What happened? Yeah, we could do 1,000. I'm going to go for 10,000 though, right? Oh, I know what it is. I modified all the key bindings for Vim to do different things. So all right, let's just make it 15,000. Why not? Okay, so there we go. Test 15,000 at the bottom, and then we'll go to the next one and run it. So that's pretty cool. So imagine that you ship an SQLite file that has millions of test cases in it. You wouldn't do that in Perl. You wouldn't maintain that as a file, but or imagine there's just an online database that has these things that you can use. That's a pretty good example of things we can go. The Ingy language, I think I explained it. We got 1 minute. So if you know a language and it's not in TestML, please find me on IRC on the Pound TestML channel, and we'll get it done in a day. Or if you want it in some language, and you know, if you're willing to just learn the language with me, I'll do that with you. Right now, between opportunities, I was looking for the perfect YAML job, actually, and it's kind of hard to find the perfect YAML job. But if you know the perfect YAML job, or you know, a job that kind of is Ingy, let me know. And you know, David wants to cut me off, but I'm going to take a couple of questions, and because. But you have to, but you're not going to. So let's do a clap. And
I believe after this is lunch. So.
Right, and it's lunch. So I will take any questions from anyone but Chad. Yeah.
Yeah, if we had a traditional Perl test, where you create an object in a method, and you wanted to convert it to TestML, would it be a case of like building chaining bridge methods and employing them from TestML? Or how would you go about transforming that into TestML?
Let me answer the way I would want to answer it, because I'm not sure I have the mental model of what you want to do. But in TestML, basically you're all saying, take this, wrangle it, and expect this. And so what you do in the TestML is make this side look as beautiful as you can. Don't worry about the wrangling yet. This side look as beautiful to the user, somebody who's reading the test. This is what I got, and this is what I expect in this situation. What's the simplest way and the most clear way I can do that? And then you chain the bridge method. You divide up you can have one bridge method that does it all, or you can kind of combine them if you want to refactor them so that they do different things. And you can have bridge methods on the right-hand side too, saying, this is what I really want, but it's more programmatic if you transform it this way first. And at the end of the day, the left-hand side and the right-hand side have to be whatever the test operator supports. It has to be a string, a Boolean, a list of arrays, whatever, that type of thing, or a list of regexes. We can talk more. Any other questions? Yes?
So in list, don't we usually quote something? So does linking not quote, or why don't we just sort of trick it into using the list like that?
I don't really know Lisp so much, except that the function comes first and the parameters come after. So, and you could do that in JSON. So in JSON, in Lingy, an expression is an array that has at least one element where the first element is the string, and that's the operator name, and it maps to some function somewhere. And then it takes the rest of the things, if there are any, as arguments. So
I guess in most lists, that's true, but we can quote the list, and then that's not true. So we get that.
right. So I can actually kind of show you how that works afterwards if you want to see. Anything else? I'm getting hungry too. Thank you.